Okay.
All right. Okay, so you all should be seeing a window pops up on your screen letting you know we're recording this program. So please click on continue and the pop-up window should go away. And please do not leave because we have a really, really cool program that's coming up. All right. And right now I'm going to share a quick photo release as we have to do that to make sure you guys know what we're doing. This program is being recorded. By entering, you are consenting to your likeness and possibly appearing in the promotional materials for Los Angeles Public Library and NASA Globe / IGES. So we just want to make sure you're aware of that. Okay, and I also want to take I want to take this time to formally welcome everybody. Happy New Year and welcome everyone. We're super excited to have you all joining us through Zoom today to kick off the 2022 NASA Globe Cloud Challenge. And the theme this year is the theme of this year's challenge is clouds in a changing climate. And I want to take this time to also thank the Library Foundation of Los Angeles and also our behind the scenes staff who help us to bring these virtual programs to you. This is a fairly casual program, so please bear with us for any technical difficulties. During the program, please feel free to share with us your thoughts, comments, and questions in the chat. You would also find a Q&A button on your menu bar, probably at the bottom of your screen or on the top of your screen. If you have questions, we highly recommend you use that button to ask questions. It's easier for us to sort through them and answer you much quicker. You can also click on raise hand button if you want to ask the question verbally, and we will unmute you. Now, here's the very, very important part. If you'd like to win a limited edition of the 2022 NASA calendar, make sure you stick around until the end and pay very close attention to the presentation today, because we'll be asking a few questions from today's presentation, and that will be the chance, that will be the time and the chance for you to win the calendar. And if you are the winner, please make sure you email me, Vivian, at vber@lapl.org. Our staff is, Steve is going to type that in the chat. Make sure you copy and paste that somewhere so you don't lose it. After the program, make sure you gave me your name and also your mailing address. We'll be sending this to you. And even if you live in India, we will mail it to you, okay, if you win. All right. Let me see here. Okay, so that's everything that I just mentioned. Okay, and now we're ready for our quick icebreaker question. So what comes to your mind when you see or hear the word cloud? And you can go ahead and use if you have a tablet or a phone, you can go ahead and scan the QR code on screen, or you can type, we should have the link also in the chat that you can just click on it and type in 3 words that comes to your mind when you hear or see the word or think of the word cloud. And this is going to help us form a word cloud. So let's do that for about a minute, and then we're going to share the result with all of you. Every time when I do this part, I always wish that we have music in the background. Okay. I think we're probably at the 30-second mark. Okay, let me see if I can share my screen here. Okay, I hope you guys can see. Here is the word cloud that we have formed so far. So when you guys think of the word cloud, I see forever, cool, little, puffy, white, fluffy, yes, fun, calm, sky, rain. Yeah, that's the first thing that came to my mind actually, usually when I see like super thick clouds. Amazing, weather, cumulus. Ooh, okay, we got big words there already. Bubble, awesome, dreamy, yes. Thank you so much for this awesome word cloud. We will be saving this and sending this to you in a follow-up email so you guys can see what are some of the words that come up to everyone's mind. All right, so I'm going to stop sharing here. Oh, actually, no, I'm going to go back to my slides. Okay, so now we are going to dive into our program today. And of course, yes, we are talking about clouds. Our special guest today is going to tell us everything about the importance of clouds to our planet why and what NASA wants to know about them, and also how we all can help NASA scientists and researchers study the changing climate by observing clouds. And so here's our special guest. Joining us today is Jessica Taylor. Jessica grew up in Florida, where her love for thunderstorms led her to pursue a career in atmospheric science. Jessica began making global weather observation in 2000 as a student at Florida State University. Now, as a research scientist at NASA, Jessica is the principal investigator for globe clouds. And this year, more than 220,000 observations of clouds and sky conditions were documented and submitted to the globe worldwide database. That is really amazing. And now we are going to let's hope this time we're going to triple that number. Maybe we can. So without further ado, let's welcome Jessica.
Thank you so much for that very generous introduction. And I love seeing all of the comments in the chat. Thank you for sharing where you are from. I appreciate that, and great to hear from some folks that I already know. And for those of you who I haven't met yet, I really appreciate you taking the time to join. So I'm going to go ahead and start to share my screen and put the presentation on for us. Okay, somebody give me a verbal, yeah, you can see it, great. Okay, so as they said, I'm Jessica Taylor. I am a physical scientist at NASA Langley Research Center. That's in Hampton, Virginia. Fun factoid, NASA Langley is the first NASA center because we're close enough to DC, but far enough away. And we have over a 100-year history now. So it's a real pleasure to be a part of NASA Langley. And I must say, growing up in Florida, I knew a lot about NASA in terms of the space shuttle program, but I had never necessarily known about the amazing work that NASA does in studying Earth science. And I honestly had not ever considered or realized that that was a path that I might take in my life. So I'm happy to share that with you. As a quick reminder, we are going to do a hands-on activity here in a little bit. So if you don't already have this stuff, go ahead and start gathering it. You're going to need a piece of paper just to make some notes for yourself. So if you don't have that and a writing utensil, don't worry about that so much. But you will need a light source. So that could be a flashlight, or just use the flashlight on your cell phone. And you'll need a few assorted things that you'll be able to test to see whether or not they're transparent, translucent, or opaque. So we're going to test opacity. And it might be things like, I've got a glass here and this little piece of paper thing. I've got a coaster, a tissue. So just grab some things that you might have around you, and we'll get that started in a few minutes. So let me tell you just a little bit more about myself. Thank you, Vivian, for the kind introduction. As she said, I am from Florida, grew up in Florida, which is the lightning capital at the time of the world, and it's certainly the lightning capital of the United States. And growing up right outside of Tampa with all of this lightning, I was fascinated by thunderstorms. I just thought lightning was beautiful. And I had a lot of curiosity around lightning and how can the sky make lightning. And I had a great high school teacher. Shout out to all the teachers on the call. I had a great high school teacher who encouraged me to do some research on it and to write a little thing up about lightning. And what I learned was that scientists were still learning about lightning, that they didn't know. And I just thought that was so cool that you could have a job studying something that you were interested in and learning about something that you're interested in. And to me, that's kind of one of the definitions of science, right? This idea of learning and discovering about the natural phenomenon. And that not until my senior year of high school, that was how I decided I wanted to study meteorology. And that's how I went to go to Florida State University. And at Florida State University, I did get a degree in meteorology. I also got a couple of other degrees because I just really like learning. So I have a background in finance and one in education. But at Florida State was when I got introduced to the GLOBE program, which is this international citizen science program that we're going to talk about tonight. And I became a GLOBE student, which meant that I got to participate, like everyone else in the GLOBE community, in collecting real science measurements at my school. And so I would climb up the 3 flights of stairs, although technically it would be 5 by the time you got up there, um, to our roof in Tallahassee, Florida, which is hot and sticky. And I would do that every day. And I would collect precipitation, rainfall measurements, temperature, pressure, relative humidity, aerosols. And I learned so much. And I learned about weather by doing that. And I really credit participating in the program like that as a student, even though I was an adult student at the time. I really credit that program with helping me see myself as a scientist because I was doing science. And that is really what helped give me the confidence to even pursue a career as a scientist at NASA, which is amazing for me to think about. And now I get to do the GLOBE program as a part of my professional job. So I help implement the program and I am the principal investigator. I lead the GLOBE Clouds team. Um, in my personal life, I am married to a climate scientist, so it's sort of all in the family here. And we have two beautiful daughters who are 7 and 9 years old. So I am highly familiar with the struggles of that schools are going through right now, and thankful to all of the teaching staff. And we also have two little kitty cats, two boys that are now 17 and 18, if you can believe it or not. So they are senior citizens in our house. So I mentioned to you about I really credit the GLOBE program with helping me see myself as a scientist. So I just want to share a little bit about what I mean by that and what I learned from doing citizen science. In other words, going out and collecting these scientific measurements, even though at the time I was not a professional scientist. That's what being a citizen scientist is all about. Sometimes we call this volunteer science or community science. And what I learned was about the skills in making observations. And I really would suggest to you that the more you make observations, the better at it you get. You start to notice things a little bit more, notice some different details. I got to learn how to read an instrument. It might sound silly because you know how to read a thermometer, but it does take some skill in understanding an instrument and why it works the way it does, and being able to be very precise and accurate in that measurement that you're taking. I also learned how to ask questions. Same thing here. The more questions you ask, the better you get at asking questions, which is really important for a scientist. And I collected and analyzed the data that I had, and I just really had this better, broader appreciation for weather in general, because that's what I was studying in Globe at the time. Was I was studying weather. So I want to ask you guys to think about that a little bit, about this idea of citizen science and contributing as a community to this broad research base, because that's what the GLOBE program is all about. It's international in scope, over 120 countries participating, and there are multiple science protocols for how to collect the measurement. We're going to talk this evening, tonight, or morning, wherever you're joining us from, about clouds in particular. We have over 200,000 community members, citizen scientists participating in this program. And something that I think is very unique is that it does have multiple federal agency support here in the United States. So NASA is the main sponsor of the program, and it is supported by NOAA, National Science Foundation, and the Department of State. And the University Corporation for Atmospheric Research in Boulder, Colorado is who implements the program with us. Now, if you were listening to Vivian, I started at Florida State in 2000 and joined Globe back then. So I've actually been a part of the Globe program for longer than I've been at NASA, which is kind of cool. So as we start to really focus on clouds here, I'd love for you to type into the chat, what is your favorite cloud and why? You don't have to use the scientific name if you don't want to, but what's your favorite cloud and why? Maybe you haven't thought about it before. Mm. Well, I'm going to give you a hint. My favorite one is the one on this screen, which is a cumulonimbus cloud. And that's because of this passion I have and interest in thunderstorms and lightning. And I just find all of that energy that's in there very exciting. So Vivian or Teresa, would somebody share with me some of the answers that are coming in through the chat?
Other people are also saying rainy clouds and fluffy clouds and stratus clouds. Some people know some cloud names, cirrus clouds.
Wispy and see-through clouds,
Ooh.
cumulus. Interesting. Lenticular because of the shape and formations near mountain peaks. Wow.
My second favorite would have to be cirrus, the wispy clouds, just because I think it's really fun when I do my hand symbols for clouds to make that motion. I was also a dancer, so there's like a little dancer in me that wants to be a wispy cloud up there.
We have stratus, we have rainy clouds again, snow clouds, big fluffy clouds.
So we must like our precipitation, huh?
And clouds in front of the moon.
Ooh. Well, you can keep them coming in. I'm going to go ahead and move on forward with our presentation here. And on the slide, I am sharing the globe cloud chart. And so in the globe program, we ask our participants to characterize the cloud types. So tell us the cloud types. And on this image here, you can see the scientific names for the clouds. But I wanted to briefly mention, let me move something out of my way here so I can see our screen. How do we even come up with these names? And not so much the history of how we come up with the names, but knowing that the name means something in terms of the cloud type. So I want you to look, if you can, on your screen, hopefully it's big enough for you, that you can see that the shape of the clouds change from one picture to the next. So the name of the cloud is indicative about all of these different things. And so one of the things we could look for is shape to tell us the difference between one cloud type and another. So if you indulge me here, I'm going to show you my hand gestures to help me remember the shapes of the clouds and the names. So we have, someone said that they liked stratus. So stratus are flat and they're almost blanket-like. So if you do this with your hands, stratus, stretchy stratus. It's almost like you can do like a big yoga pose with this, stratus. These stratus clouds tend to cover most of the sky because they're stretchy. Another cloud type is cumulus. Cumulus are your big fluffy clouds. And this is my hand symbol for cumulus. And the reason that I do this puffy cumulus, is because cumulus clouds are formed because of warm air rising and mixing. That's how you get that shape that makes it look a little bit more like a cotton ball or cauliflower, is because of what's happening atmospherically. You have this warming air that rises and mixes. So that's how you get cumulus shape clouds. And then the other one on here, we have cirrus, these high wispy ones, wispy. And then another high cloud that's man-made are contrails, which is the straight line across the sky that comes out from a plane. Now, some other ways that we can help figure out what type of cloud we're seeing is by looking at the size. So particularly for a cumulus, we've got these puffy cumulus clouds, but I was saying the word big. But really, if you look in the sky, sometimes a cumulus cloud might look actually pretty small. So one way to tell is if you hold your fist out to the sky, if the puff, an individual puff is about the size of your fist or bigger, it's probably a low level cumulus, so just a cumulus cloud. If it starts to get smaller than that, like maybe your thumb or two finger size for each puff, it's altocumulus. And then really high up, it's probably like the size of your pinky when you hold it up there. That's a cirrocumulus cloud. And so that's another way that we can describe the clouds. And that also has to do with the altitude of the clouds. So these things all kind of come together. Another big question, is it precipitating? So there are only two types of clouds that have precipitation, and those are nimbostratus or cumulonimbus. And so I mentioned cumulonimbus being one of my favorites because it's the thunderstorm cloud, and that's the only one that's the thunderstorm cloud. And nimbostratus, oftentimes that's more associated with ongoing sprinkles. So this, if you have more persistent rain, that's when you would get that. The color of the cloud is something else that you can notice and that can tell you a little bit, help you identify what your cloud type is. And the other thing I want to mention is opacity, which we're going to be talking a little bit more about. Opacity is the idea of how much light comes through the cloud. So if the cloud lets a lot of sunlight through, it's probably a very thin cloud. Or if the cloud actually winds up blocking sunlight and reflects it back out into space, then that is an opaque cloud. It is a thick cloud that is blocking the light. Another little fun fact, all clouds are actually white because they're made up of water droplets. The reason that sometimes they look gray is because you're not either because of the thickness or because of the expanse of the clouds, you're not getting that reflection of sunlight off of them. And that's why they wind up looking gray. Interesting, huh? Okay, so let's learn a little bit more about opacity. So we're going to move into the part of our program where we're going to do that hands-on activity. So if you've got your stuff, go ahead and grab it and put it in front of you. And we're going to talk through the Sci Girls. If you've never heard of Sci Girls, we've partnered with them a couple times. They're most widely known as a PBS television show, and we do have a clouds episode with them. So we're doing their Cloud Clues activity, investigating opacity. And let's go over those definitions again. We want to know how much light passes through our materials. Our transparent material is going to let the light pass through the material. A translucent material is going to let some of the light pass through. And opaque would mean that very little or basically no light comes through the material. So step one, if you do have a piece of paper or if you're just talking with your family, I want you to think about how might you test your materials to figure out their opacity. So I'm going to let you think about that for a moment, and you can feel free to draw or describe in words on your piece of paper, or if you happen to be with other people, feel free to chat it out for a little bit here. I'll give you about 30 seconds to think a little bit about that. All right, let me see if I can stop my background here for a second. Here we go. So let me show you my test for opacity. So this is how I'm doing it. This is by no means the only way to do it. So I'm going to use a light source. I'm going to take a material, and then I'm going to actually hold my light above the material, and I want to see how much winds up on the table, if I can still see the light on the table. You may have another design, and that's absolutely fine. Come up with whatever design you want. So the next step is we're going to go ahead and try that out. And you're going to write down on your list, or just kind of keep track in your head, whether or not each material, which category it fell into. So now we're trying to categorize our materials, much like we're categorizing our clouds by the names that we use. So take your light source. I'm going to use my cell phone here because I have it handy. And you're not going to be able to see what I have here on the table, but I'm going to take this piece of paper. And I definitely see a lot of light through it. Let's see, maybe I can hold it up in front of my camera here. Oh, you see the light? Yeah. What about something else that I have? Let's try my painted coaster. Oh, you don't see nearly as much there. I bet if I took my headphone case, oh yeah, no light shining into the camera now. So that's opaque. What about a tissue? Clean, by the way. Clean tissue. Whoa. Yeah, which one had the most? So pick up a few things in front of you and go ahead and jot down some notes about it. So in this activity, what we're practicing here is a few things. We are learning how to categorize and sort. We're also learning our definitions of opacity. And then we've also done basically a very quick engineering design activity where we were designing an experiment in a way to test out how we could check whether or not what fell into these categories. Now, why is this important? How does this even relate to clouds, other than like some clouds let in light and some clouds don't? Well, this is actually very important to understanding climate. And this is one of the key questions that scientists around the world are asking about, is about not just are there clouds or more clouds, but what type of clouds and what is their really opacity? Because in this diagram here, we've got yellow arrows. The yellow arrows are indicative of incoming solar energy. So energy from the sun. And you can see that in the high cloud, these are our high thin clouds. High thin clouds let most of that sunlight come right through. Now, puffy cumulus that's low to the ground, it's actually going to reflect a lot of that sunlight back out into space. Now, everything with a temperature emits energy. You emit energy, your laptop emits energy. Everything that has a temperature, actually, everything that has a temperature, it's a piece of paper. It all emits energy. That's how we can be able to test the temperature of something often. But our planet, Earth, the surface, is also emitting energy, and it's trying to go back out into space. And that big puffy cumulus cloud, yeah, it reflects some of it, but that big puffy cumulus cloud also emits energy back out into space. But a high thin cirrus cloud winds up acting a lot more like a blanket, because not only is it trapping some of that energy, but it is so cold that it is emitting at a lower energy. It's emitting less than the other cloud. And so altogether, high clouds tend to trap heat. And so they wind up warming our planet overall. And low clouds reflect a lot more of that sunlight and they act to cool the planet. Right now, we have more cooling clouds than we have warming clouds. It's probably a good thing based on everything that's going on. But that's exactly what climate scientists are interested in knowing is, are the clouds changing? How are they changing? What, are you getting more of one type of cloud than another? And how will that then impact the climate more? So it's not enough to know that there's a cloud. We want your detailed information about the cloud type, the opacity, and anything else you can tell us about. So I'm going to pause here, pause, and take a few questions before I talk just a little more about the cloud challenge itself. So if you have questions, feel free to raise your hand, and I think Vivian will call on you, or you're also welcome to type it in the chat and someone can read it to me. And Vivian or Teresa, just so you know, I'm having trouble seeing any of the hands just because I'm on a small little laptop.
Okay. All right. I'm seeing one person raise hand here, and we're going to unmute this person. All right. Go ahead. You're on.
My question is, how long have you worked in NASA?
Thanks so much for that question. I have been at NASA now for almost 15 years. And that seemed like a long time when I first got started. But I have to say, one of the reasons I love working at NASA is there's always something new and exciting to learn. And that's something that I really like in a job is having something new to look forward to and learning more. Thanks for that question.
Okay. We have one more person raise hand, and it's Florence. And now you can go ahead and speak.
Hi, can you, hi.
I can hear you.
In that diagram that you showed us, you said that the high clouds trap more heat and you refer to them as cirrus clouds. So does that mean all cirrus clouds warm the planet and all cumulus clouds, which you refer to as the lower cloud, they cool the planet?
As a scientist, you know, I will probably never say all, but basically most of them, yes. Which the reason I give that small little caveat there is when you are making observations for GLOBE, we're asking you not just the cloud type, but also tell us about the opacity. Because remember, as we see clouds, they are very dynamic, right? Like they're changing very quickly in terms of building and also when they change into another formation of cloud or etc. So while we're either building a cloud or while the cloud is dissipating, that cumulus cloud really might not be completely opaque, right? And we've sometimes seen, I can see a big scene of cumulus clouds where there's like a puff that somehow got separated because of the wind. And that one appears to me, I'll use this word, optically thinner. So it's a thinner cloud. So I won't say all, but the vast majority of cumulus, low-level cumulus clouds are cooling the planet, and the vast majority of high-level cirrus-type clouds are actually warming. Thanks for picking up on that.
Thank you. And we have one more person raised hand here. It is, I hope I pronounced her name correctly. It's Yaharth Sharma. You can now speak.
Why are clouds important?
Mm-hmm.
Why are clouds important? Yeah, so clouds are really they're a critical component of our water cycle, right? We would not have the water cycle if we didn't have clouds. That is a critical component in understanding our hydrologic water cycle. They're also very important for what we call this energy balance. So when we think about the climate, what we're actually looking to see if there is in order to have energy balance, we want the amount of incoming solar energy to be equal to the amount of outgoing energy emitted by Earth. That would make us balanced. When we have an imbalance, then that means we're either getting cooler or warmer. And as you've probably seen in the news, what we're experiencing right now is that our planet is actually warming. So we are at an imbalance between the amount of incoming solar energy and the amount of outgoing energy emitted from Earth. And that can have there's a number of reasons for that because the Earth is a very interconnected system, but clouds play an important part of that. And they're kind of tricky to understand because they change so frequently. And that's why it's really important to study them. Thanks for that question. Now, don't worry, we also have time at the end for some more questions. So Vivian, is it okay? Do you want me to keep going and then we'll come back to questions?
Let's answer one more.
Sure.
Let's see here. We have one from Florence. We have someone said they have a question that's not cloud related or climate related. So
Okay.
for that, we probably will save that question until the
Yes,
end.
and I'm also happy to type my email into the chat for everyone who might still have questions at the end.
Yes. And so for now, I'm just going to have, we're going to go back to Florence one more time. So Florence,
Okay.
you can go ahead.
Hi, I'm sorry. I don't mean to hog up the conversation, but you mentioned when you were answering my question, you mentioned about the opacity of the cloud that you have to take that into consideration too. And
Yeah.
I believe you said that the sunlight that comes through the cloud is what causes it to be white. And if when we see a gray cloud, it's because not enough sunlight is passing through. Is that?
Yep, either not enough sunlight is passing through or you're not getting enough sunlight like reflecting off the ground, right? So some of that cloud whiteness is because sunlight is not just coming from behind it, but it's being reflected from all around it, right? So there is sunlight being reflected off of the pavement and off of the grass. And if you have a thick layer of cloud that is blocking some of that, you're just not able to get all of that reflection enough to make it look white to our eyes.
Okay.
All right. So let's go back to the presentation and we can answer the rest of the question at the end.
Absolutely. Sounds good.
Mhm.
And if you think about, the cloud itself, clouds are actually droplets of water, or in some cases, ice. And so they're going to be reflecting all these wavelengths of light to make it look white in color, so that sunlight. So let's shift the topic a little bit about, now that we've learned some about clouds, how can we participate in this cloud challenge that we have? So this cloud challenge coming up here starting this weekend is about clouds in our changing climate. So let me play a very short video for you, and then we'll explore some more of the resources that we have.
Did you know that clouds can both warm and cool our planet? Keeping an eye on clouds helps NASA study our climate. We need your help capturing data about clouds where you live. NASA Globe Cloud Challenge 2022, Clouds in a Changing Climate. January 15th to February 15th, 2022. Participate by taking cloud observations with the Globe program's Globe Observer app. Or by classifying cloud photos through Cloud Gaze on the Zooniverse online platform. Learn more at observer.globe.gov/cloud-challenge-2022. Did you know that clouds can both warm and cool our
Yes, you do now. So let me take you to our main landing page. And Teresa, if you can plop this link in the chat to observer.globe.gov/cloud-challenge-2022. And I'm going to click on this and you let me know if you do not see my window. But this is our main page for the Cloud Challenge. And I want to share some of the key resources with you with the time that we still have here. You may have heard in that short promo video that there's actually 2 ways for you to participate in the challenge this year. So if it's safe for you to go outside and you're able to go outside, you can go outside and observe clouds and report that back to us by using the Globe Program's app called Globe Observer. And I'll show you a little bit more about that in a second. And so you will actually participate that way by telling us what you see in the sky. The second way that you can participate is by classifying clouds through an online platform called Zooniverse. Zooniverse is a very large citizen science project where you can oftentimes classify a lot of photos. And in this case, we take the photos that you as community members send us through the Globe program. We push them onto our Zooniverse project called NASA Globe Cloud Gaze. And then the Zooniverse community, which you can be a part of, can classify those photos. So we're getting kind of a double layer of information about those photos. We'll have what the Globe observer saw, as well as what a number of different participants in the Zooniverse community classify that photo as. And that's helping us do some more research with the data that you're submitting. So let's take a look at the app in particular. And I want to play this video for you about how to use the app, and the app itself is going to step you through how to make an observation. And this will give you an idea of how fast an observation can really be. There's some music in the background, but I will probably do a little bit of extra narration for us. So let me pull it up on YouTube here to make it actually bigger. So once you open the app, you'll click on clouds and you can make an observation. And we're going to use your phone or your mobile device's location and timestamp to really document that part. And we just start asking you questions. What does the sky look like? Obscured would mean there's stuff blocking the sky. Those are all things we'd want to know. You'll tell us about cloud cover, which is the percentage of the clouds covering the sky. And if you see on there, you don't have to be super specific. You're just trying to get, again, into a category of cloud cover. You may be able to answer the question for us, what is the deepest shade of blue that you see in the sky? This question about the shade of blue and this next question here about visibility can tell us a little bit more about aerosols or air quality. And so sky visibility is looking straight in the X direction across the horizon. Then you'll basically start telling us about your cloud types. What cloud types do you see? And we do have some other tools in the app to help you figure that out. And you'll see as you're clicking through, it'll also ask you about opacity. And so opacity is going to be, tell us what the deepest opacity is for the cloud. Then we also want to know about where you're standing. So tell us what's on the ground, because believe it or not, satellites sometimes have trouble with that. And then the most fun part for you and also for the researchers are the photos. So you're going to turn your phone like she did and start capturing the pictures of your sky. And then last but not least, you have to send your observations to us. And what's great about you sending your observations to us is that'll get shared with the worldwide database in Globe, and it'll also be shared with us at NASA. So we direct access to your observations as well. Now I'm going to go back to the Cloud Challenge homepage. And again, you're welcome to visit this Cloud Challenge homepage and click on these different videos that we have. And that was the one about how to use the app. And there's one about introduction to classifying on the Zooniverse platform through Cloud Gaze. So in the interest of time, I'm going to scroll down, even though there are some really great features here, like this Globe Student Vloggers is a great video showing you the power of students engaging with their community members and asking how have clouds changed in their climate. All really, really great videos. I do want to let you know that we have a number of scientists who have agreed to speak with the community, and they will be sharing some of their insights about clouds. And this will be going out through social media, and you can find a bunch of Instagram reels on the Globe Program Instagram channel. Now, you already know about this webinar because you are here with me right now. We also have another opportunity to learn a little bit more about Globe and Cloud Gaze. The American Meteorological Society is having their first ever Community and Citizen Science Symposium, and that's coming up next week. And the link there if you're interested. We'll also be posting on social media videos from two of our educators. We have an educator that's going to be doing that same Cloud Clues activity that you just did. So you might want to see what they did, as well as somebody who's going to be sharing about Earth's energy budget and how they use Cloud Gaze in the classroom. So I mentioned your observations go into the Globe database. This is called the Globe Visualization System. You can click on this and see everybody's observations from all over the world. You can click on each of those circles to learn more about their observation, to see the photos that they included. And if we're lucky, which a lot of people are able to do this, there will be what we call a satellite match. What does that mean? Well, when you're making your observation and you send it to Globe, it comes to us at NASA. And actually our job is to look to see if we have satellite data from the same time and location. So if you're on the ground and there was a satellite overhead and we match to Aqua, Terra, Calypso, they're all polar orbiting satellites, and we match to multiple geostationary satellites. So basically almost any time you might be able to get one of these matches. And what I mean by get the match is we will email you. So the email address that you use to sign up for the app is the email address we're going to use to email you back a table that has your observation and information from the satellites. Now, your observations might not be the same. That's okay. And that's highly probable sometimes because you're on the ground looking up. You're seeing the bottom of the clouds, right? You see the first low level of clouds. A satellite looking down, it sees the tops of the clouds and it sees the high cloud deck first. And so really by putting your two perspectives together, that's how we get a complete picture of clouds. And that's why your data as citizen scientists from the ground looking up is so important. So if you have questions about satellite match, this is a place where you want to come and look at it. And I mentioned geostationary satellites. Well, we are very excited about the upcoming GOES-T launch, which is scheduled for March 1st. And once that becomes operational, we will also be able to be matching to that satellite as well. So that's pretty cool. So I realize I'm skipping through some things, but I really want to touch on just a few more things before we come back together and do some questions. If you are an educator calling in, thank you. And I want to share that there are pacing guides. So these are 1 week pacing guides that address clouds, and each of them has a guiding question to them. And you can see the age ranges. We have one for grades 3 through 6 and one for 6 through 12. As an educator or a librarian, the Clouds Resource Library is where you'll find some of the hands-on activities and some videos to help you with programming. but I'm guessing and hoping that there are a number of families on the call right now. So let me click on this. This is our family guide where we'll talk about how you make observations, satellite matches, but we also have a number of other hands-on activities. So if you enjoyed doing that opacity activity, there are a number of other activities here that you might like. And we also have some of these versions in Spanish. And Cloud in a Jar is probably one of the most popular activities we hear from families and camps that they love. Cloud estimation, this is me with my girls doing an activity where we practice how we would estimate the cloud cover by using percentages or fractions. And you can see we have a number of just really cool, fun activities you can do together as a family or even in an educational setting. We also have some videos from scientists, so you don't necessarily have to wait for all the videos that are coming out for this cloud challenge. We have a number of them already. And in fact, there's one on clouds and Earth's climate already there. And last but not least, I wanted to mention to you about career connections. So we already had a great question about careers, but this is a page that'll tell you a little bit more about being an atmospheric scientist. You can get some profiles of other atmospheric scientists and learn a little bit more about them. So I wanted to make sure that I shared that with you in case that's something that is of interest. So let me go back to our Cloud Challenge page in our presentation. And I just want to give a few reminders here before we do questions, and I let Vivian ask some questions too. Remember, 2 ways to participate in this cloud challenge about clouds in our changing climate. If it's safe for you to go outside and you're able to go outside, you can make observations through Globe using Globe Observer app. You could also go online to Zooniverse and look for NASA Globe Cloud Gaze, and you can classify the photos that come in through Globe. You could also do both. You could see if any of your photos that you took in the app make its way over to Cloud Gaze. That would be really cool. And I wanted to also mention just some reminders about how do you even get this app, right? So you would go into your, wherever you get your app. So it's a free app available for Android or iOS devices. You're going to look for Globe Observer. After you download it, you'll need to create an account and you will need an active email address to do this. Now, for anybody who's on the line who is under 13, we ask that you do this with your family's account because we want to make sure that this is focused with families and adults as well. And make sure you double check that email address. We'll send you a password and then you're basically ready to get started and can make observations. And in the app, if you like how it's set up and you like making observations of clouds, you might also want to give some other things a try. You know, when we were talking about why clouds are important and how do we understand climate, well, it's an Earth systems question. Everything is related to something else in the Earth system. And so being outside, practicing and getting better at observing clouds might also help you observe your land cover and trees. In the trees, we turn your phone into a clinometer so you can measure the height of the tree. And in Mosquito Habitat Mapper, we help you eliminate breeding sites for mosquitoes. So those are some of the other cool functions that you could do. And the last thing that I wanted to mention before I turn it over to Vivian is when you're in the app and you're not sure if it's this or if it's this, that's okay. That's what crowdsourcing and citizen science is all about. The more you make observations, the better at it you're going to get and the more comfortable you're going to get. But also when you crowdsource, the more observations we get, the better data we wind up getting as a whole. So please kind of push through that little bit of discomfort and send us what you think the sky looks like. And that's exactly why we have the pictures there to help us out. So I'm going to pause there before questions. So Vivian, I believe you have some things you wanted to share.
Yes, I do. I'm gonna share
You want
my
me to stop
screen.
sharing?
Yes.
Yeah.
So very quickly, thank you so much for this amazing presentation you did and also the fun activity hands-on part. Now I just want to share a couple of things that we're offering from Los Angeles Public Library's website that you guys can also check out. It also ties into the cloud challenge. So let me get this on screen. So here is my notes. Okay, so if you could go ahead and scan the QR code or make a note, take a note of the address, the link at the bottom. So this is Los Angeles Public Library's cloud challenge site. And the reason I mentioned this is that while we have all the information that Jessica just mentioned on the site, there's one thing that's really unique for people, all of you, if you are participating from LA County or LA area, is that if you scroll down on the website, I hope I can share this. I don't know if you can all see my website instead of my slide. So this is my our website here. If you scroll down to the bottom, you will see what we call the story map. Right now, it's at 0 observations. So that's because we haven't officially started the challenge yet. So we're hoping all of you living in LA or in California or anywhere close by, if you would go ahead and participate by make your observation and share your observation through Globe Observer, they will be captured and it will reflect on this map. So we're hoping
It sounds like Vivian's audio went out.
Yeah, Vivian, we can't hear you right now.
let's see here.
Oh, you're back.
Nope.
You're back. We can hear you.
Okay. All right. I have to unplug my headphone. So anyway, so here is the website, and we're hoping that as soon as you pretty much when you contribute the observation, it will reflect on the map here, and I think it will be in the gray dots. So the more gray dots we get, that means the more observations are coming in. And again, that also means the NASA scientists are able to use your data for their research. All right. And last but not least, before we go to our trivia giveaway session, is I do have one more slide to show. That is, we actually have you can again scan the QR code on the screen or make a note of the link. I'm going to show you. I'm going to stop sharing here because you can see that. You guys see me here? Here's me. Okay. All right. So we actually have these Globe Cloud Observation Kit available for checkout in 21 of Los Angeles Public Library branches. And I know your question will be, well, how do I know which of the 21 branches are the one that's carrying the kit? So if you go to that link I showed you earlier in the slide, that's our LAPL Mayside kit page. It will tell you which of the 21 branches of the 73 locations we have that actually currently have this kit for you to check out. Okay, each time you check out, you can keep it for 3 weeks. You can use everything in there to do your observation. Okay, so I just want to make sure I mention that. Now we're ready for our trivia question part. Yes. Let me see here. Okay, can you all hear me good? I feel like I can't hear other people. Okay.
We can hear you.
Okay, good. All right, so let me pull the question out because I got the question from our, let me see. I got the question earlier. So here's the first one. Now, the way we're playing this game is that after I read the question, I'm going to count to 3. Whoever, if you know the answer, please don't shout. Well, you can't shout out because I have to unmute you. Thank goodness. Okay. Yes. So what you're gonna do is you're gonna use the raise hand button. Okay, and all of us, there's 5 of us that's manning the platform right now. we will keep an eye on seeing on the participant list to see who has the hands up first. And then we unmute you and you can tell us the answer. Okay? And if your answer is correct, then you are the winner for our calendar. And I'm going to show you, here is the calendar. It's very, very beautiful. It's amazing. And inside every page, there is full of these awesome images and a lot of great information about NASA science. All right, so this again is limited edition, and I won't even get to keep one. So you guys are super lucky. In addition to the calendar, you will also receive a cloud chart that you can, it's perforated in the middle, so you can kind of punch it through, and then you can use that to kind of match to the sky to sort of figure out which type of cloud that you have. And then there's also the cloud identification chart, which Jessica was showed us earlier too. So these will all come in the package. And last but not least is another little flyer here of different citizen science project that's included in the Globe Observer app when you download it. Okay. All right. So now here comes our first question. Are you guys ready? I'm nervous too. All right, so all of us, please keep your eye on, once I count to 3, please tell me which one is the first person that have the hands up, okay? All right, here's the first question. What types of clouds may be warming our environment? Is it high thin clouds, cirro clouds, or what type of clouds produce rain? Okay, which question are we having? Jessica, which question should we have? It looks like there's 2 questions.
Yeah, so I think you were asking that first question. Which cloud types warm our planet?
And you're going to count to 3, right? So
Yes, I'm going to count to 3. So
I'm going to
everyone,
lower everybody's hands, and when
Yes.
Vivian says 3, then you go.
That's right. Okay, here we go. 1. Okay, Florence, your hands down, please. Okay, someone else has their hands up. Okay, good. All right. No, hands down. Hands down. No hands right now. Okay. I'm going to count to 3. No, hands down. 1, 2. No, Allison, you can't cheat. 1, 2, 3.
Oh, Allison, I saw Allison go first.
I think I saw Alex and Allison pop up at the same time. So, we'll open to both. So that's let me unmute Allison first, and you can tell us your answer, and then Alex, you will have your shot too. Okay? So Allison, here we go. Go ahead.
I think it's the cumulonimbus.
Which one? What is it again? We can't hear you.
Sorry, I wasn't meant. I think it's the cumulonimbus and the nimbus status.
Is that correct, Jessica?
So we're actually looking for the answer here of a high thin cloud.
Okay.
Interestingly, the cumulonimbus cloud is a very thick cloud, right? So it basically goes from the low level all the way up to the top. So it does block most of all of the sunlight that's coming in. It does emit just a little bit because it has such a cold temperature at the very, very top, but it blocks most of sun's energy coming in. So it really typically acts a little more on the cooling side.
So does she have the answer correct or no? That's not right, right?
Yeah,
right.
Here we're really looking for the answer of the high thin cloud. But like I was saying, what's interesting about the cumulonimbus is it is considered both a low cloud, and if you were thinking about it that way, it could be considered high in that that's where the top is. And so it emits very, very little compared to some of those other low level clouds.
All right, so looks like Allison didn't have it correct, right? All right, so then we're gonna move on to the next question. Hopefully you can try one more time. All right, so everybody, your hands down, and then we are going to ask the second question. This one should be very easy. Again, you have to wait for me to count to 3 before you raise your hand. Otherwise, we'll be here until midnight. So let's not do that. Okay. What is the theme of this year's Globe Cloud Data Challenge? Okay, I'm going to count to 3. 1, no. 1, 2, 3. Okay, we have someone here that doesn't have a name. I see a bunch of dashes. So I'm going to allow you to talk. Okay, what is the answer? Are you there? Could you guys hear him or her? No? Okay. All right, that didn't seem to work. So do you guys know who was the second person?
I believe it was Nora, but did you?
I think it was the same. Yeah.
Ah, okay.
Okay, so that's a new Nora. Nora, you can go ahead and answer.
Clouds.
The theme, the entire theme. Clouds something. No? Okay, we're gonna ask for the next person. I know I mentioned that only one time right at the beginning, so that might be why it's tricky. All right, who is the next person that you guys remember seeing? That was the third hand. I think it was it Steve? Steven Friends? All right, I'm gonna go with that one. Steven, do you know the answer?
Is it clouds in a changing climate?
Yes!
Yay!
Awesome! Thank you. All right, so don't forget to email me. We should have my email in the chat again. You can go ahead and email me your name and your address. Okay, and we'll make sure we send you the calendar. All right, we're going on to the next question. Where is my question? All right. How much does the Globe Observer app cost? I'm going to count to 3. 1, 2, 3.
0. It's
What?
free.
What is?
I think it was Florence that was
Yeah.
first. Yeah.
That's who I saw too.
So Florence, you want to go ahead and answer? Florence, are you still there?
Yes, the Globe app is free. You don't pay for it.
Yes, thank you. Awesome. All right, don't forget to email me your name and your address. I'll send you the calendar. Okay, I think we are down to the very last question that I have here. It is, oh, I like this one. Okay, be ready. Here's the last question. Which state is nicknamed the lightning capital of the US? I'm going to count to 3, so put your hands down. 1, 2, 3. I missed that one. Who was the first?
I think it was Dominic.
Dominic? All right.
I believe so.
Okay, Dominic, go ahead. Allow to talk is not available because Dominic is using an older version of Zoom. Uh-oh. Do you want to go ahead and type the answer in the chat? We can look at the answer in the chat as well. No! All right, who was the second? I think the second person with the one with a bunch of dashes in the participant list. So let's try it again. You can go ahead and unmute yourself and speak out if you want, or you can use the chat to answer. What is the lightning capital?
Los Angeles.
No. All right, who's the next person? Teresa, do you remember?
I believe it was Abrielle.
Okay, Abrielle, go ahead.
Is it Florida?
Yay!
All right, Gabrielle, make sure that you go ahead and send me your name and your address. We'll mail you the calendar. All right, I have one last question because there was one that we didn't get to send out. So here's my one last question. So it has to do with the last thing I mentioned. So you can check out the NASA globe observation, clouds observation kits in Los Angeles Public Library. How many branches actually carry these kits? So it's a number, and I'm going to count to 3. Whoever can answer correctly, you will get that last calendar. All right, so put your hands down. I'm going to count to 3. 1, 2, 3. Okay, I am seeing, I think it was the person with the dashes again, who's the first one to answer, have their first hands up. So go ahead and answer the question.
It's 3.
It's what?
3. 3.
No, it's not. Okay, and the next person I saw was Muskane. I hope I have your name. I didn't say your name wrong, but I'm going to allow you to speak now. Do you know the answer?
It's full.
Huh?
Full. F-U-R.
No, it's not. One last one. Okay.
I think it was Stephen.
Steven. All right, Steven. Let's try you again. Do you know the answer?
Is it 22?
No! But you're very, very close.
Very close.
Very, very close. All right, I'm going to give someone a try here. Ryan Pereira.
23.
You're getting colder.
Yes. Okay. Who else I haven't called? Let's try someone new. Is it Danila? Danila Estrada? Yeah, Danila, do you want to try?
Yes, 21.
Yes! Thank you!
Yay!
All right, we have finally gave away all 4 calendars. Yay! All right, thank you all so much. And I know we have so much, you all have many awesome questions that we'd like to answer. So what I'm going to do is I will be forwarding all the questions in the chat to Jessica, because we're like 13 minutes over. And so I'm going to forward all those questions to Jessica and give her your email so she will be able to answer your question directly that way via email. All right. And
I'm going to go ahead and type my email address in the chat box. So if you have questions about careers or if you have questions about clouds, you're welcome to email me and I'll do my best to get back to you. I hope you really enjoyed this and I hope we can see your observations coming through. And one last note, the data challenge is just fun because it's a great time for us to focus and pay attention on this. But to really understand climate, we need a long-term record. So you can continue, we hope you continue to make observations beyond the data challenge period. So we welcome those coming in and I hope to see them for a long time coming.
Thank you so much. That was so well said, Jessica. And we really hope all of you will be joining us. And we would love to see all those great thoughts coming in on the maps. I can't wait. I can't wait. I'm going to be, I don't know if I'm going to be the first one, but I'm definitely going to be contributing. And just so you know, I know right now we're still in the midst of this pandemic. And one thing I enjoy doing a lot is really every so often I'll just step out to my backyard or just when I walk out, I really just look up and look at the clouds. It just kind of really calms me down and really makes me feel a lot better. So that's also another thing you can do. Just kind of, shift your mind a little bit from the craziness of the pandemic and think of something else great. All right. Thank you again, Jessica, for joining us. Thank you, Teresa. Thank you, Diane. Thank you, Steve. All the staff that's helping us carry this, making this program possible. And please go ahead and start doing your observations starting on the 15th of January. Thank you so much, and we'll see you next time. Bye-bye.